Hello, grade 8 learner. Welcome to another video lesson in mathematics, where we will be discussing an application of the concepts of triangle congruence. This lesson is based on the K-12 curriculum competency. The learner applies triangle congruence to construct perpendicular lines and angle bisectors. It's another great day to learn, so prepare your pen, paper, and module as you start watching and learning from this video lesson. For this lesson, refer to your Quarter 3 math module entitled Applications of Triangle Congruence. In this example, we are given that line CD is the perpendicular bisector of segment AB. We are going to find the measure of segments CA and DB. We begin by observing the problem. First, let us identify the given and what is asked. We are given segment AB, which is bisected by line CA. We connect the endpoints to form line segments, where segment CB measures 5 units and segment DA measures 6 units. We are going to solve for the measure of segment CA and segment DB. Next, we recall what a perpendicular bisector is. As a perpendicular bisector, line CD divides segment AB into two equal parts and creates right angles at their intersection. Let us process what we know. To solve for the measures of segments CA and DB, we can use the perpendicular bisector theorem. This theorem states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. In our illustration, we see that point C is on the perpendicular bisector CD. Applying the theorem, we can say that C is equidistant or equal in distance from points A and B, which is on segment AB. The perpendicular bisector theorem is an application of triangle congruences. To show how, let us prove that side CA is congruent to side CB. Let us name an unnamed point as point E. From there, we see that side CA is part of triangle CEA and side CB is part of triangle CEB. Let us do a simple proof. From the given, we know that line CD is a perpendicular bisector of side AB. Next, from what we know of the definition of the perpendicular bisector, we state that side AE is congruent to side BE. From the figure, we state that side CE is congruent to side CE by the reflexive property. Since CD is a perpendicular bisector of AB, that means there is a right triangle formed at the intersection, which also means the triangles CEA and CEB are right triangles. From the proven congruent parts, we have proven that the two legs of the right triangles are congruent. Thus, we state that triangle CEA is congruent to triangle CEB by the LL theorem. And because the triangles are now proven congruent, we can say that side CA is congruent to side CB through CPCTC, or that congruent parts of congruent triangles are congruent. Let us solve. Now that we've shown what the perpendicular bisector theorem is, let us use it to solve for the measures of sides CA and CB. To solve for side CA, recall that we have proven that side CA is congruent to side CB. Therefore, we say that side CA also measures 5 units. To solve for side DB, recall that D is a point on the bisector. Thus, D is equidistant to points A and B on segment AB, which also means that the sides created from points DA and DB have equal distances. Since side DA is congruent to side DB, therefore side DB measures 6 units. Let us now state our conclusions. Given that line CD is a perpendicular bisector of AB, we solve for the measure of segments CA and DB by applying the perpendicular bisector theorem. Thus, we learn that segment CA measures 5 units and segment DB measures 6 units. Congratulations for finishing this video lesson. Now apply what you've learned by answering the activities in the activity sheet. Happy learning! We'll see you again in our next video lesson.